one or two. Okay, so we have started. So welcome everybody for the Meetup group, from the Bangalore Meetup group. So welcome all to the Bangalore MuleSoft Meetup. And today we have Sunil Krishnamurthy from Salesforce, who will be just showcasing us on the topic of MuleSoft Vectors, connected with Azure AI and the MuleSoft Agent Fabric. Welcome all. I hope everybody is all ready for the holiday season. And I know Nitish is not as of now, but soon he will be once he is free from all the work. Okay, so can you go to the next slide? And here are the meetup leaders: Nitish, Jyoti, Sham, and myself, Pranav. So before taking much time, I'm just handing it over to Sunil so that he can take it from here. And we have started the recording. I hope nobody has any problem for that. And thank you. Sunil, you take it from here.
Yeah, thank you, Pranav, and thank you for all the meetup organizers for giving me this opportunity to present. And I thank all the audience who have joined on this holiday week, making time to attend this. Just about myself, I'm working as a technical architect at Salesforce working on the MuleSoft product. Have 15 years of experience working on various domains. On enterprise integrations, certified on multiple clouds, and passionate about AI, lesson learning, trying to keep up to it. Right. So today we are going to talk about two topics. One is MuleSoft Vector Connector with a demo, and we'll also see the MuleSoft Agent Fabric. So there are two topics. We'll try to cover both of them, hopefully, and we'll with the Vector Connector to begin with. So before I start, even though I'm from Salesforce, there's nothing to do with where the company that I'm working on. What I'm presenting is more of out of my interest, my individual contribution. So don't take it that's something coming from Salesforce, right? Okay. So what is vectors, right? They call it is an engine of RAG. Why do we exactly need the vector search? So when you want to search a set of PDF files, or when you want to search a bunch of images, the traditional search you can't do that, right? Or you want to do a keyword search, all that relational database, the like keyword will is all broken. It will not give you the result that you want, right? So how do you search the documents of the PDF or words or images? How do you search? So the solution is the vector search. What it does, it converts the text into an high dimensional numerical representation called as vectors or embeddings, right? So, so it converts the text into embeddings, which is nothing but a numerical numbers. And we can store that number and search happens on top of that number, which we will see that. Where do we use the vector search? It is used in the RAG, right? It is called retrieval augmented generation. And RAG is the next gen AI pipeline, right? So RAG is the architecture that uses vector to make LLM more intelligent or reliable, right? So instead of when you go to your any LLM like ChatGPT or Gemini and search for if you want to understand your HR policy of your company, right? Mostly the public LLMs might not know, right? So you need to give the document has a context to the LLM so it can answer your questions on your HR policies better, right? So what is the impact of doing this? So it solves two critical problems. One is of LLM, one is hallucination and knowledge cutoff. right? Hallucination, making up the facts, which is not true, giving you the wrong information. Knowledge cutoff, I was telling the public LLMs might not know the HR policy of your company, right? So, and also the recent events, it might not know. So you can feed that information as a context to the LLM using vector or the RAG. Going forward, there are two main phases of RAG. Phase one, indexing or storing the data. So if you want to store a data, if you want to search a PDF, first you need to store the embedded content of that PDF in a vector storage. So how do you do that? MuleSoft has provided the to do that. So these are the steps for storing the data. So first step, you need to load the data. Example, you want to load a PDF, right? There are three options that are supported in MuleSoft. One is local. It can be within your local system or within your application. You can load it from Azure Blob or Amazon S3. Once it is loaded, you have to split or chunk the data. To split or chunk, you don't need any AI model, but you need any open source libraries to do that. One of the libraries is LangChain library, which can split or chunk your document. Once it is splitted, next is you have to convert each chunk to embedded, which is you convert to numerical number. So for that, you need a AI model. So MuleSoft connectors support all these listed AI models in order to embed or vectorize your chunks. Once the vectorization is ready, you need a storage to store it, right? Like any relational database, Oracle, SQL are all relational database, but you need a vector database to store the vectors. So these are the listed vector database that MuleSoft connector supports. Few of them are free, few of them are paid versions based on the available options. So in this demo, what I'm going to show, I've highlighted, I'm using a local data store. To embed, I will use Azure OpenAI, and to store, I'll use Azure AI Search. So this is the first phase where you chunk the data, embed the data, and you store it in a vector database. Once you stored, now is the time to query your data. This is the phase two. Now a user will come and they will write a query. Hey, what is the policy of taking a paternity leave, for example, right? So what that query has to be embedded now. Embedded in the sense, convert the text to a numerical number, right? So the tip is you have to use the exact same embedding model used in the indexing phase. For example, if I go back, here I'm using Azure OpenAI model. So even here, I have to use Azure OpenAI only so that your index and query, if it is using the same model, it gives a better result. Once you have embedded, using the embedded, you can use the vector search. On the background, the MuleSoft connector uses HNSW algorithm for searching, right? And it provides the result for you. What you can do, using the result, you can construct a prompt for the LLM. So it gives the result from your document, but it will not be in a presentable format for the user. LLM can make it more presentable. So you take that output of the vector search, you construct a prompt and give it to the LLM. You give the output of the vector search plus the user query input, what you got in the first step, right? Now LLM can understand the context, understand the user query, and generate a presentable response to the user. So for LLM, you can use MuleSoft Inference Connector or Einstein Connector. So these are the two main phases. Quickly, we will see the demo for vectors. Okay. I have two flows. as I was explaining. One is vector store. This is the first storage phase. So which will read the document from my local. I have just what source main resources. I have a health insurance policy which I downloaded from internet. So I have a SBI general insurance company, some insurance policy from SBI. It will read the document, parse the document. For parsing, we need to use this connector, MuleSoft Vector Connector, and you need to give a library which can parse. So I'm using LangChain library. So in the pom.xml, I have added the dependencies and the libraries for LangChain here. So LangChain for the parser. Okay. Okay. Now, and then after parsing, I'm going to chunk the document. So I'm giving the size as 500 and overlap has 10. So if the document has, let's say, 10,000 characters, it will chunk every 500 characters, right? So every 500 will become one chunk. And for every chunk, it will, I'm using the next generate embedding. So generate embedding, as you told, I'm using Azure OpenAI. So all these are supported models. Azure OpenAI giving the endpoint and the API key. So that will do the embedding, convert the text to the numerical, multi-dimensional numerical. And then I store the output of embedding in the vector store. For storage, I use AI search model connection. So here I'm using the URL of my AI search and the API key. Okay, that's the flow. And coming to the query, so I'll send a query here, and the input query, I will embed it and query the output. Okay, so what I want to show is the storage. I'm storing it as the store name as 1223, so that I'll make sure I search 1223, today's date, save. I'll go to Azure now. Okay, and resource groups. So I have three items running in my resource group. One is Salesforce OpenAI service. I have a spin, which I'll use for embedding. And then AI search, I use for storing the embedding. So let me go to AI search. On the indexes, there is only one index called load F02. Okay. So when I load the document now with this store name, health insurance 1223, that should come up here. Okay.
Hey, Sunil, sorry to cut you.
Yeah.
Actually, I have a question. So this connector which we see in the middle, these are all vector connector, and there are different operations to it, correct?
Correct. Yeah, these are all vector connectors.
And the configuration, what you are showing in the Azure section, is it as a MuleSoft architect or developer, it's our responsibility, or it will be taken care by the Azure team?
And it depends on your project, right? The Azure, if there is
Generally,
already an Azure team, you will have to work with them. But if
but
you have access,
who own
yeah,
this in generally? Generally, infra team will own this,
yeah,
creating
infra
the
team will
indexes
hold.
and all.
Yeah, correct. Creating the index will get auto created, but spinning up a service, right? Azure AI or Azure Search infra team will own. You will have to raise a ticket to the infra team and get it created, get the API key created, so you can utilize that.
And is there any way where if I have created my model, like these are open source models, so does MuleSoft support that also if I have something in the house created as a company?
So I gave you the list of open source models, right? So it supports only that for now.
Okay, no
Raju.
in-house build models.
No, no, not in-house for now.
Okay, yeah, please continue. Thank you.
Okay, so yeah. Okay, quickly I'm debugging it. Let me take my Postman ready. So my store is running on the path as store. I'll just trigger. I'm not passing anything. I got the request. I just want to walk you through what happens here. So it is reading the document from my local, which is the SBI health insurance. When it read, it is all like base 64 format. So you need to parse it, right? Using LangChain. Once you parse, you see get a proper text document you get with all the content that is there in your PDF. After parsing, you need to chunk it. So chunk, I'll go forward with the chunk. So chunk is completed. So I'll take the entire output of the chunk, put it in my text document and show you, give you some idea that how it is chunked, right? You see, this is one chunk. There is double quotes. Every chunk is separated by a comma. Okay. So this is chunk one. Let me put it to the new line. See, this is first chunk. And if you see the total number of characters somewhere on the bottom, you see 450 characters. I had given 500, so it has chunked 450. So likewise, it has taken the entire PDF and it has chunked like a comma separated chunks, right? Next, I want to generate the embeddings. So I'll go forward.
Sorry, how we decide the chunk size and what is the impact of selecting smaller chunks or bigger chunk size?
So yeah, yeah. So chunk, you will, I mean, the recommended is automatically 510 are decided. The lesser chunks, it will create a lot of memory storage, right? It will create a lot of embeddings. The higher chunk, the processing will become slower. So you have to stay optimize, do the round of testing and see which segment or chunks works better for your document. So it's not a fixed recommendation, right? It depends on your use case, the size of the document that you're uploading, all that.
So we may have to do some performance testing to just
Correct.
come up to reach that number. Okay. Yeah. Thank you.
So what I did, I just did the embedding. So I'll take the embedding, show you what exactly is embedding, what it has done. See, it's all numerical numbers. Let me go to the top. So I did not get the full payload because it's too huge. These are the embeddings. So this is the first chunk, right? For the first chunk, it would have created an embedding here. So if I find the close bracket, so it's a comma separated, right? This is the embedding for my first chunk. See, it says so big. My text is just 450 characters. For this chunk, it has created this is the embedding. Yeah, till here. Okay, it uses some vector algorithms to generate the embeddings. It's all positive and negative integers, numerical numbers. Okay, so for every chunk, it has created the embedding, and for embedding, it needs AI model to do that. And now the complete embedding, I'm going to store it in the Azure Vector Data Store. Okay, stored. Now we'll go to the Azure. Let me refresh. it was not there. Now it's come. It is showing 0 and 0 bytes, but it will take a few seconds or a minute to give me the document count in bytes. Okay, so let it. So it's still loading the document. So that is the storage part, right? Now we have to see how the query would work. Let the document get loaded. It should be quick. Okay, let's search and see what happens. My application is still running, so I will change the endpoint to query. So what I want to query here, let me open the document. Okay, so this is the document. Let's some text to query. Okay, so let me go with this. There are some definitions for different things. So let me take copayment, right? Copayment and its output in the body. What is the definition of copayment? Okay, let me send it as a text because a text, and let me clear everything. Add a breakpoint. Now let me check the Azure. Okay, see, it's now loaded. Document count 203. Maybe it has 203 chunks. The total memory is 3.6 MB or total 4 MB around. Now it's ready to search. Come back to Postman and I send this request. Okay. So it will embed the request that I have sent. So you see the embedding, the numeric embedding of the that I sent. What is the definition of copayment? So what happens now? The vector search happens. It will take this embedding and it will compare with the embeddings that is stored, right? And whatever the closest probability it will give. How do you do that? I'm giving the minimum score as 0.7. Whichever the probability is 0.7 and greater, and maximum of 5 results, not more than that, is what I want. Okay, so let me go forward. Now it is doing the search. Search is completed. Now when I come back to Postman, this is the response it has given. You see, there is only one match and the score is greater than 0.7. And this is the text it pulled out, right? Oh, sorry. Yeah, sorry. Yeah. That, see, this is the date it pulled out. I'll show the document also. Co-payment means the agreed share of claim amount which is to be borne by insured for each hospitalization. You see that line has come here. Co-payment means that line has come. See, all these additional lines might have come from maybe this para, right? The date of discharge from hospitalization or all that the claim made, all it has pulled, but it has pulled the right definition also. But this is what I was telling. This is not a presentable response to the user. That is why you need a LLM to clean this response, right? So now you understood how storage, how you can store and how you can query the vector database, right? Now, how do you introduce a LLM here? Have another flow. Yeah, here. The same query, nothing changes. So you pass the query, you embed, and you query, create the prompt for the LLM. So I'm using inference connector. I'm connecting to OpenAI. Okay, I'm using GPT 4.0 mini model, and how do you construct the prompt? So this is one of the sample, right? So you have to give the role, it is a system, content, you are a helpful and professional healthcare policy assistant. Answer the user questions only based on the context below. What is the context? It is a RAG output. RAG output is nothing but the vector query output. So I have saved the vector query in a variable called RAG output, which is, this is the payload dot response, this response. Okay, that goes here. And the user question, the original user question also. So you give the output of the vector, you give the user, until you have to answer based on the context only. And give this complete prompt as an input to the LLM. This one, right? I'll add a breakpoint. What is this? This is just RAG, right? So I'll just change this to RAG. I'll keep the same payload. Okay, it is deployed. And got the request. So I generate the embedding of the request, do the query. Okay, I understood why. I should have changed to 1223 here. Let me quickly do and redeploy. Okay. Okay, let it deploy. Okay, deployed, request, got it. Generate the embedding, query the vector, store variable, the RAG output, the output of the vector store, and it's not a presentable response. So I'll set up the, create the prompt. This is the prompt that got generated. See in the context, it is, we have the RAG output, and I give this to LLM. Let's see what we got. So this is what. So LLM took the context, it understood the user query, it combined both, and it gave the result. So if you see the document, what is co-payment? If it, the definition of co-payment is agreed share of claim amount which is to be borne by insured for each hospitalization. This is exactly what is there in the document. This is a presentable. So that is why you need to combine a vector along with LLM to become more presentable. And whatever we did now is the RAG, right? This vector plus LLM combined will give you the RAG of flow. Okay, this concludes the demo for the vector connectors. So if you see the vector connectors, we have used most of them. We also have query all. You also have remove. So in the Azure storage, you have this storage. If you want to remove, you also have a connector. You can remove the storage so that you can upload the fresh one, right? So you can have, for storage, you can have a AWS connectors, right? Whenever a document is loaded to S3, it automatically triggers and gets stored in the vector storage. There are a lot of use cases for this RAG. For any new employee onboarding, you can load all the onboarding documents and he can query and understand the different things in your organization, right? All your design documents, requirement documents, you can store it, and people can query and understand the different questions that they have against your design and requirement documents. So there are many use cases that you can solve using this. Okay. Now let me go to the
connector for calling that LLM.
Sorry, what is it?
What was the connector for calling the LLM?
Let me show you that. It's called MuleSoft Inference Connector. Okay.
So do we need to add any dependency from any point platform to means so that we can see this connector, or by default it is present?
No, you need to add. This is a free connector, right? You need to import it from your exchange into
Okay.
your any point. Yeah.
Okay.
So all vector connector, inference connectors, all you can just import from exchange, but you need to have an OpenAI account to connect.
Is there any way we can get this studio project? What you're showing right now?
Yeah, I'll work with the organizers on that
Okay.
later.
That would be helpful. Thank you.
Okay. Okay, great.
Yeah, sorry, I have just one question.
Okay.
We need to
Yeah. So the first thing is, since we vectorize it and store it in a database, let's imagine we have some documents which constantly keep updated by one or the other person, and they keep updating it. Then how do we handle that one? That is first question. Next question is, let's imagine that all the documents are stored in like kind of a web pages, like on the Confluence. So when it is stored on the Confluence, let's imagine we can use web crawlers or web scrapers. So so what's the difference between that and this, and when this can be used and when that can be used? Yeah,
Okay.
these are my
You have two questions, right?
yeah,
What if a document keeps updating, right? So
yeah,
that's what to load the document, I told there are three options, right? Local, Amazon connectors, and Azure. So if you update any document, let's say you store all the documents in Amazon S3 bucket, and you update any document, you can configure an automated trigger. The document request will come to your application and you can overwrite your vector store. In real time, any document update will trigger your flow and your vector will be updated. You can do that. The other thing, if your data is in the internet, right? So there are other connectors MuleSoft has called web. What is that? Crawler. Okay, so which will go to your provided internet web pages. It will read the data and give you. You can use the connectors to read your web pages and give it to your vector connectors to vectorize it. So there are options for both of your questions. Okay.
So in your project, sorry, I have another question. So in your project, you mentioned one file, right? So assume that the same policies, you might have multiple, say it's a health insurance, and you might have a document from multiple source of insurance provider for a company. So I want to load couple of it can be uh, multiple providers gave this document. I want to load all three. In your search you mentioned one file. Can I have n files instead of one files search?
Yeah. You can load all the files into one searchable vector storage.
Oh, one
Right?
searchable vector storage. Okay.
Yeah. So you search, all the files can be searched with one command. Yeah. Okay. We have 20 minutes more. I want to go forward with Agent Fabric. Then we can take questions if we have. Okay. So Agent Fabric, when you think it is an orchestrator for the agents, right? First of all, how do you create an agent? Right? Quickly, I will show you. I just showed you this flow, the RAG flow. If I want to convert this to as an agent, it's very simple. The same, instead of HTTP, I added a to A task listener. So from the exchange, take the A to A connectors, and you have a task listener connector. You add that. So now this flow became an agent, right? So A2A, you need to give the A2A server. This is the agent listening on endpoint called healthcare policy agent. Okay. And you give what is this agent description. So this accurately frame and deliver the policy specific responses. So you have to give what is the skill of this agent. Basic, I've written basic lines that is, I mean, it searches the vector store and gives you the output of the policy. That is the skill. So this is how you create a A2A server, right? And load it to A2A task listener. Okay. And the last, after LLM, you need to format the response like the A2A listener, what it expects. So you need to give in the request when it gives you the unique message ID. That message ID, you send it back in the response, in the ID. So it will tag the request and response together, right? And the LLM output, you put it in the text field. Rest all are static. Only this line will change. Now this is an agent now. So to test, we need to test this agent. How can we test? So you can test it in Postman also, like this. And you need to publish the request in JSON RPC format. Okay. So let me debug this and vector query. Let me make sure I will change here. I will run. I will not debug, so it will be faster. So I put a different question here, or I can put the same question as earlier. What is the definition of copayment? This is the question. So you see the request structure. This is how you call an agent. Okay. The agent is deployed. So this is where the agent is listening. Post the request. What is that? Okay, I got the response. So the state is completed and the text field will have the response. Okay. Now this is an agent. So you can develop agents in MuleSoft pretty easily, but agents internally should do some intelligent work. So I have vector and LLM to do this. Okay, I'll stop. So I have an agent built with MuleSoft. I also have one MCP server built, which I'm not gonna get into that because it's not in the scope of the session. But this MCP server, what it's capable of doing, it can create an account in Salesforce, right? So I can create any, right? Some, right? Run. It is already deployed on my Cloud Hub. So it created it. I got the Salesforce account ID. Using the account ID, I can even put that account ID and run. It gives the result. So I have a MCP server which can create an account in Salesforce, also can search an account in Salesforce. So I have one agent and one MCP server. Now we will see how we can use this in Agent Fabric. What is Agent Fabric? Right? Let's try to understand on a fabric itself. This is a piece of fabric. On this piece of fabric, you can dump a bunch of agents. These agents can be hosted on MuleSoft, or it can be hosted anywhere else. It doesn't have to be on MuleSoft. Agents can be hosted in on the OpenAI, or it can running on LangChain, anywhere, right? You can dump bunch of MCP servers. It doesn't need to be running in MuleSoft. It can be running anywhere, right? And what Agent Fabric does, it can orchestrate between agents and MCP servers. For example, when you build a MuleSoft flow, how do you orchestrate from one connector to other? You write an arrow, right? And if you want to go in different directions, you use a scatter gather or a choice. So you tell the flow based on the input request which route it has to take. But here, who will guide when a user sends the request? Who will guide that the request should first go to agent A, then go to MCP, then go to agent B? So there is no arrow concept here. That is why that orchestration will be done by a broker. Broker itself is an agent. Okay. How will broker know to orchestrate, right? So it needs the power of LLM plus a detailed instructions. Using the LLM and instruction, broker can orchestrate between the agents and MCP server to provide the output, desired output for the incoming user query. Together, we call it as agent network. So agent network will have a broker, bunch of agents, and a bunch of MCP servers. Okay. This is nothing but agent fabric. So agent fabric is there are four highlights here. One is discover. Each agent, MCP server, and broker, you can publish it to the exchange, like how you publish any APIs, right? So you can discover and reuse these agents and brokers and orchestrate. Agent broker will act as an intelligent orchestrator. Govern. You can apply, like for any API, how you apply the policies, rate limiting policy and all that. For agents and MCP servers also, you can apply their own specific policies in API manager. And you can, using agent visualizer, you can observe how the broker and agents are connected. So it gives, so everything is built on the well-known platform like API manager, exchange, everything we are reusing for agent fabric. This is the architecture. So agent registry where you register everything on the top. Then there is governance policies. For MCP, you can add schema validation, PIA detector policy. For ATOA, you can add agent card, rate limiting, all that policies. Then orchestrator, agent broker will orchestrate, agent visualizer will give you the connectivity and all that. Okay. This is same thing what I explained. Okay. So it's a centralized agent management, complex orchestration and all that. We'll skip this. We come to this important one. You need to understand the prerequisite and considerations for using agent fabric. To use agent fabric, you need to have a package of MuleSoft. It doesn't come with the free account. Okay. You need to have, for deployment, you can deploy on CloudHub 2.0 with a private space. You cannot deploy on a shared space. Okay. You can also deploy in the runtime fabric, but documentation says is a limited availability. So I'm not sure more about that. You need to have a managed Flex Gateway. Even this doesn't come free with the free account. Managed Flex Gateway you need to have, and you need to have a LLM. It's today Agent Fabric supports only two LLM. One is Azure OpenAI or the direct OpenAI APIs. Few considerations, only these authentications are supported, basic client and any point client. OAuth is not yet supported for Agent Fabric. And A2A 0.3.0 is supported. You know, A2A is a protocol invented by Google, right? They are continuously working to improve the protocol. Right now, the latest protocol is 0.3.0, which is supported by Agent Fabric. There are few A2A protocols, few features are not supported, like task history, push notification, all that is not supported, might be supported in the future releases. Only text-based prompts are supported, image and binary are not supported. Okay. and LLM and deployments that I already told. These are the considerations. So how do you start your development and deployment, right? So you can do only on any point ACP, right? You cannot do this development on Studio. On any point code builder only you can do this. First step, you need to create the agent network project. So it will automatically create a template for you. Okay. Next is you need to set up the agent network gateways. This will deploy one ingress and one egress agent network gateways on the Flex gateway, which I will show. Next, you will do the development. Very simple. Just two files you need to work on. One is the agent network YAML file and exchange JSON file. Just two files. Next is you will publish the agent to the exchange. So your broker, your agents, LLM, MCPs, everything will be published to the exchange. Next, you will deploy the agent network. So this will deploy to cloud of private space. This is the order to develop and deploy. Okay, so now I'll quickly open that, my ACB. I have already developed my YAML and exchange file, which I will show you. So what I was telling you that these steps, I created the project. Next is set up the agent network gateways. So I come here. So in runtime manager, is opening. Let it open. Let me, yeah. Okay. On the left side, when I go to Flex gateways, you see there are two gateways which are in running. Okay. One is ingress and one is egress. So this will automatically get created when you run this command called MuleSoft Agent Network Gateways. MuleSoft Setup Agent Network Gateways. It will ask you what business group you want, and then it will ask in which environment and all that. When you give all that, it will create that. Okay. Next step is the development. Let me quickly walk you through on this. So this is a simple YAML file. So here, let me.
So just in the previous step, can you show me where you run that for the to create a gateway?
Yeah, on the top, you see there's a search bar.
Uh-huh.
Click on the search bar, then type a greater symbol, and here you can search your commands. Here.
Okay. Thank you.
Okay. Okay, so here what I have, this is a template that MuleSoft would already give. So here I put the name of my broker. So first you will have a broker, right? Next I'll have my agents, MCP servers, LLM, and the connections. This is the structure. First you need to define your broker. My broker is a healthcare policy broker, and a simple description of this. And what is the skill of your broker? It provides information on healthcare policy only for verified customers. Okay. And what your broker needs LLM plus instructions, as I told you earlier. So it is using OpenAI GPT-5 model, and I'm giving a set of instructions. I'm telling you, use create account tool from this MCP server to create any new customers. Okay. Always ask for customer ID or customer name before giving the healthcare policy information. If the customer cannot be verified, politely inform that we cannot provide the information. For verified customers, route all the healthcare policy information to the healthcare policy. So this is a detail. So what I'm telling the agent, don't give the policy for everybody. If the user is present in my Salesforce account object, only then provide the healthcare policy for that. Okay. So links healthcare policy agent. This is my agent name and my MCP server names. So this is my broker configuration. Now I need to give the details of my agents. This is my healthcare policy agent. This is my MCP server. My LLM is OpenAI. And the broker needs the connection for the agent and MCP servers, right? So here are the connections. For the healthcare policy agent, my healthcare card URL will come from the exchange.json. This is my healthcare policy, and this is where my healthcare agent is running. So here on my sandbox application, 3 items are running. One is my MCP server, and one is my A2A agent that I just demoed in my studio, right? Have deployed both of them. And this is the public URL for my agent. So I copy this and give it here, give it here. This is my agent and this is my MCP server. And this is my OpenAI key and this OpenAI host URL. Okay, so all these connections can be parameters can be added here and referred here with this has here. Okay, so all the connections are set up. But this is only a read only, right? So you see a read only. This is just a representation of your configuration. That's it. So if you have multiple agents, multiple MCP servers and all that, you will just update this file accordingly. Proper instructions for the broker. Once your 2 files are ready, what is the next step that we have to do? We have to publish it to the exchange. So I ran this command. After running the command, what would have happened is, first thing what it will do, it will go to the exchange. It would have, see, I'm in the Salesforce root. So it has published OpenAI, the MCP server, healthcare policy, the broker, and the healthcare agent. Okay, ignore the last one. So it has published all these. So for any other project or anything, it's the discoverable and reusable components. So it published as a reusable, discoverable assets. Once it is published, now you can deploy. When you do deploy agent, what happens in the API manager? On the left side, you have to click agents and tool instance. All your 4, what you saw in your exchange will come up here with green color, right? So your OpenAI is up and running. Your broker is deployed in rate. Your agent is there and MCP server is there. So this will come up in API manager. And if I go back to the runtime, the broker gets deployed on a private space. So see this, you will see this broker being deployed on a private space. It doesn't get deployed on a shared space. Okay, and also on the Flex Gateway ingress on the left side APIs, you'll see the broker active on your ingress Flex Gateway. Okay, so when you do this deploy, all this happens. All API manager, runtime manager, the Flex Gateway, the things gets deployed, everything automatically. And you should just wait and make sure everything comes up. Okay, now your agent fabric, the broker is deployed. Okay, now we can give it a try. So you need the URL that. Where do you get that URL? You can go to the API manager. API manager, you will have your broker running, right? Because you have to publish your request to the broker. That is the one who will orchestrate, right? The agent broker is the one which will orchestrate between all the agents and MCP servers. So I'll come to the agent broker and consumer endpoints. I will take this endpoint. Okay, that is the endpoint I have pasted here. And the request is the same, what I showed earlier, right? Which we used for the agent. Because remember, broker is also an agent. So you have to publish the message in JSON RPC format to the broker. So I'm publishing the same request. So what do you expect will happen here? I'm asking the policy details, right? Let's give it a hit, try. Now what broker will be trying to do? First, it will understand input request. It will understand the instructions that I have given, right? According to the instructions, I am telling, do not give the policy information for somebody who is not verified customer, right? So the broker gave the response, I can help, but before I provide, I need to verify your consumer identity. Provide either your consumer ID or customer name. So it did not give me the policy information. So broker is intelligent now. So now what I will tell, I'll give my name is what something, right? Right. Create an account for me. So now the broker will understand the incoming request and it will route the request to the MCP server, the create account tool. So there is no arrow marks like I told. The broker is intelligent enough to know which agent or which MCP server to use. See, account successfully created and verified, name Virat, I got a account ID also. Next, what I will do, my account ID is this. Explain me, what was that? I forgot.
Co-payment. What is
Co-payment?
Yeah.
Thank you.
Sunil, just a quick time check. It's already
Oh,
9.
okay. I mean, this is the last.
Sure. Yeah.
Co-payment. Okay.
And Sunil, it looks like it in the backend it is built on Agent Force, correct? Because the instruction LLM, it looks very similar to Agent Force. So in the backend, is it using Agent Force only to create this broker?
No, it is not using Agent Force.
But I
It's all.
remember to use this agent. No, I think the agent. I don't know, but it look very similar. The instructions and that is the same way we create agents even in Agent.
Yeah.
Agent
See,
Force.
instructions for any agent, irrespective of the platform, Agent Force or anywhere, it needs instructions, right? So Agent Force, you give instructions, but anywhere to build an agent, you have to give instructions. See, now I gave the ID and co-payment. So I verified your account, request for policy grounded. Here is the summary from your policy. Definition, co-payment is a portion. So it explained all the details. Okay, we are on time, but I was able to cover these two topics. Hope it was helpful. And thank you again for joining in. Yeah, any questions or Pranav, back to you.
Yeah, Sunil, just one question, Aditya here. When you say agent fabric is orchestrating, so what I understood is in the YAML there are the instructions key wherein there are sequential instructions. If the customer ID is valid, then only proceed and all. So that is what orchestration we are talking about, right? In the natural language.
Correct. The instructions will help the broker to orchestrate between the agents.
Just one thing, Agent Fabric is not only for orchestration. See, what I know, Agent Fabric is kind of an API manager version for agent. So it's not like agent broker is mandatory. If you have a simple agent and you just want to apply policy and govern it, for that purpose also you can use Agent Fabric. Broker is a scenario where you have multi-agent scenario, like one agent is connecting to MCP server or agent is calling another agent. Then you need to create a broker. It's not always mandatory. So you can use Agent Fabric without using agent broker.
Yeah, Fabric is just a concept here. There's nothing, right? So
Sure.
you will
Thanks,
have
Mike.
the broker and then the agents.
No, what I'm
Yeah.
saying now, broker is not mandatory.
Okay.
Broker
Yeah.
you need only when you have multi-agent or one agent is calling MCP or something. But if you have a simple agent which you only want to govern and discover, that can be done from Agent Fabric.
Yeah, it can be done. Correct. You can create an agent and govern that. Yeah.
Correct.
Yeah. True.
Because that's how MuleSoft is presenting that.
Correct.
Yeah, so then
Salesforce
there
is
is
presenting
no
it,
orchestration. If I understand what Raju is saying, if there is no orchestration, there is no need of creating a
broker. You don't need
Yeah.
to. Broker is not a mandatory part. Yeah.
Yeah. You can just create the agent, apply policies on the agent, and expose the agent as well. Yeah.
Even you don't need to create agents. Suppose if you have an agent outside of Salesforce or outside of MuleSoft, you can just discover it in the Anypoint Exchange and apply policy, whatever you want.
Correct. Yeah. We can do that. Correct. That's a good use case as well.
Okay, and I had a question put in the chat that what are the use cases, that we would be preferably doing in this rather than doing in the traditional way of API and API manager. So like the one that we have had here is a healthcare, but when there is an agent network, then that use case would fit into, right? Meaning we would use the agent fabric and do the agent to agent orchestrator function.
One of the use case that MuleSoft presented was new employee onboarding to the company, right? New employee onboarding, there are different agents which will create his account, create the ticket for his background verification, ticket account, create the tickets for his laptop, all that. So the agent broker can coordinate between these different agents to complete his onboarding, right? So there are other use cases as well.
Thanks, Sunil.
But yeah, means the common use case now means how Salesforce is presenting. Like now across the enterprise, if you see, there are so many agents. So now it is becoming difficult to manage. So that's where you can use Agent Fabric to, means you can use it as a centralized platform where you can discover all your agent and govern it and visualize it, how it's performing and all those things.
Correct. Yeah, I did not show the visualization. If I'm still sharing, I believe. So there is, if you see the visualization, this is the broker. It is connecting to healthcare policy agent and MCP server. It's just a visualizer. When you click on that broker or agent, it gives you additional information. So if there are multiple brokers, multiple agents in your organization, visualizer will help you to understand which broker is connected to which all agents and MCP servers.
Yeah. It's I guess is similar to our API visualizer in our traditional
similar to that.
Where we can see the okay.
But actually here now you can even verify whether the correct MCP servers are getting called or not. Like you have given an instruction that please verify this first, but whether the actually agent is doing that or not. So that verification can also we do it very easily with this visualizer part.
Correct. Yeah. Thank you.
Okay, sure.